Hello everyone, welcome back to the analysis section. So this video we are going to consider a typical data set for the sake of our practice. After that, I will leave this data in the description section so that you can download and then practice. So I will leave the link behind or down there. So now we have some statements which you mostly see in your questionnaires. So this one is about facility management practices for carbon emission reduction. And then we have the statements. So, and then the researcher is expecting you to respond to this particular statement based on your level of agreement, ranging from strongly disagree to strongly agree. So you can see the Likert scale responses. So statement that one example is energy saving practices are integrated into campus facility management. And then this one is being coded by B1. So when I go to the questionnaire, the SPSS to analyze it, I wouldn't be writing these long stories. So I will be using these ones. But you can pause the video and then check what each and every one of them represent. But I will also leave it in the description section so that you can take it and then practice along. So now this is the data. I have the data here in SPSS. So how do we do it? So B1, you already know it represents a lot of statements through to B12. I am not going to consider the demographic side. So this is the actual data. It has the demographic side, the gender, through to experience, and then we also have those measures. So I'm not going to analyze the demographic side. I'm going to use this one for the sake of our factor analysis or exploratory factor analysis. So how do we do it? We said the main motive behind exploratory factor analysis is to reduce it and then make meaningful decision with the data. The data is too much, so you can't be moving through it one by one when they are all trying to respond to our level of agreement to facility management practice. So these are many. So we just want to reduce it such that we can make a decision with it. So that is our aim here. So we go to analyze. Then we choose dimension reduction and then factor analysis. So you realize all the items will be here. Then you select those you want to deal with, B1 through to B12. Then we have it here. Like I told you, I don't want to do the demographics. So you come to descriptive measures. Over here, you need to make sure the initial solution is checked. KMO is checked to check the adequacy of the sample. And then anti-image is also checked. That is all for here. You go to extraction. Under the extraction, make sure the method is on principal component. If it is not, just click here and then select it, but it is already there, so leave it that way. And then you come to the analyze, make sure correlation matrix is checked. And then on the display, make sure you have the Scree plot checked. From the extract, make sure eigenvalue greater than 1 is there. So in some cases, it will just indicate eigenvalue greater than, and it will not show anything here. Just place your cursor and enter 1 yourself. But if you are using a version like my own, it will just indicate it for you. Then you say continue. And then you come to the rotation. When you come to the rotation, what you have to do is you make sure it is on the Varimax. And then you come here under the display, make sure loading plots is also indicated. But this one does not necessarily have effect. You can decide to ignore. You can also indicate it. So you say continue. And then under the score, you don't need anything. You come to option. Under the option, you come to the coefficient display formats. So suppress by size. So which means the component with the highest eigenvalue should come top. So it's just pressing them based on the sizes. So if you are big, they give you high priority. You should be placed high, then in that order. So sorted by size, and then suppressed by small coefficients. So coefficient below, then you indicate 0.40. Then I think that's all you need from these ones. And then okay. So when you run, this is our output. Now the first thing you have to consider is the KMO to check whether the sample is adequate enough. And then we said it is adequate enough from the first video when the KMO value is 0.6 and above, 0.6 and more. Now this one is 0.41, which means it is excellent or it is perfect for factor analysis. And the Bartlett's test of sphericity, we use the p-value, which is the significance here, and then it should be less than 0.05 to determine whether there is strong relationship among the variables to be considered for factor analysis. Because for the items or the statements to be considered, they should be highly related, and that is what this one, Bartlett's test of sphericity, is trying to achieve. So now when you check, you could see that our p-value is less than 0.05. 0.001, of course, is less than 0.05, which means that it is significant, and then we can proceed with the factor analysis. Now the anti-image matrix here is just trying to see or to check if each and every one of the variable is related enough to the group. That is what it means. So what does which side do we have to use? You could see we have a lot of things here. Which of them do we use for decision making? Over here under the anti-image, we have two main sections. We have anti-image covariance and then anti-image correlation. Choose the anti-image correlation. And then with the anti-image correlation, you don't need all these values. You just need the values in the leading diagonal. So the values from here, 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 or for you to indicate it fast, check the values with the AA on top of them. So, and then the values should be ranging from 0.5 and above. So that means each and every one of them. So B1, how does it relate to the group? Does it have strong relation to the group? Then you check. So you could see that each and every one of them is related enough to be considered for factor analysis. So if it is less than 0.5, that means it doesn't have strong relation to the group, and then we can consider removing it. But with this one, they all have strong relation to the group, and therefore should be considered, or each and every one is enough to be included for factor analysis. And then we call it measure of sampling adequacy. So each and every one of them. So this one, the KMO is the overall. This one is taking into consideration the individual. And then we have we come to the communalities. This one too is trying to check how each and every one of them fits into the group. So this one is just how does it relate, and this one, how does it fit into the group. So you could see that in our previous video we said it's acceptable from 0.4, but more considered in 0.5 and above. So we could see that each and every one of them is more than 0.5, which means they are highly fitted into the group and therefore must be considered. So, and then the total variance explained table is just trying to tell us the number of components that should be considered, and then the variance that is being explained, or the percentage or their contribution, the contribution of the total that they can use to represent the entire. So now we could see that you take the total here, that is the eigenvalue. So when we're running the test, or when we're doing the selection, we said eigenvalue greater than 1, and these are the eigenvalues we are talking about. So each and every one of them, you can take it from here or there, they are all the same. It is just the same thing. So eigenvalue greater than 1. So this, the last one greater than 1 is the component 3. So from component 4 down, they are all less than 1. So this 3 component is enough to represent the 12 items. And then the total variance explained by them, they have represented 80.42% of the entire, which is enough. That means the rest from 4 to 12 just takes only 17% or around 17%. Yes. And then the Scree plot here is confirming the number of factors to be considered. So you take items before the flatness. So these are the factors. 1, 2, 3. These 3 factors or components are being out of, or they occurred before the flatness. So after these 3 components, from here it just becomes a flat horizontal. And when it is flat this way, we don't consider it. Or you check any of them that is less than 1, we don't consider it. So we could see that all from here downwards, they are all less than 1. So these are the eigenvalues, and these are the number of components. So this 1, 2, 3 should be considered. So, and then we come to the rotated components. So now we have, out of the 3 components, we now trying to put them into the groups, the 12. So that these 12 items should be put into 3 groups instead of 12. So they should now be reduced into only 3 groups. And then group 1, that's component 1, it takes into consideration B12, B11, B9, and then B10. So these 4 items belongs to one group. And then component 2, B7, B5, B8, B6, they also belongs to another group. Component 3, in that order. So that means that each and every one of the groups, these are what we have. So instead of now dealing with 12 items, we are dealing with 3 items, and it is easy than with the 12 items. So basically, this is how we go by the analysis. So in our next video, I am going to explain to you how we report these ones in Word form, such a way that your supervisors will accept it. So let's get in touch. Let's now move to the next video. Have a great time. Bye.